Okay, so welcome back to the part two, quick revision session on digital circuit, right? So we are going to talk about complements now. Okay, so we'll now talk about complements. Okay, already we have discussed the conversion and we have seen a base system and all positional weighted system and all, right? So we'll talk about complements here. So two kind of complements basically we'll talk about is R minus 1's complement, okay, and R's complement, right? Okay, where R is the radix here, right? Okay, R is the radix here. So we'll see that R minus 1's complement is equal to it will be like R to the power n minus R to the power minus m and number itself here, and this can be written as R to the power n small n and capital N, right? So to convert, suppose we will try to convert, to convert R to the power R minus 1's complement, right, to R's complement, right? So what we have to do here is we have to add, add R to the power minus n. Okay, then you will get R to the power R's complement, right? So we will also see what is the application of these complements, right? So the very first complements we will talk about here is the nines complement or a tens complement, because if R is equal to 10, right, so this will be tens complement, right, and R minus 1 will be 9, means nines complement. Okay, so we'll understand this through example here. So example is going to be what? Find nines complement of what? Find, suppose question is like that, find nines complement of 327.45, okay, which is given in decimal, right? So you have to find the nines complement, right? So let us take directly the the method, so method 1 is very complicated. If you're going to find the nines complement using formula, right, that I have told you, that R to the power minus n, okay, and minus, okay, this formula was there. I told you R to the power minus and R to the power minus m and capital N. This is very complicated. So here is the trick here. Whenever they will ask you to find nines complement, so you have to subtract this given number with 9999.99, right, and just subtract it 327.45. okay, so once you will subtract this, so you will get here that is 4, 5 and 276, right? Okay, so this is what the nines complement is. Okay, this is what the nines complement of a number. What is this? This is the nines complement of, okay, whenever the decimal is given, the base 10 is given, right, and you have to find R to the power minus what? R to the power minus sorry, R minus 1's complement, right? So what you have to do, you have to subtract 999.99 to this. Okay, so you'll get this. And if you want to find the tens complement from the nines complement, right, I mean if you want to find the tens complement of this, right, so what you have to do here is find the nines complement, right? To find tens complement, right, what you have to do first is find nines and add, okay, you have to add 1, okay, add 1, or if it is in decimals, you have to add 0.01, 0.01 kind of, right, then add 1. Okay, what we have to do, let us take so we have got nines complement, okay, nines complement of 327.45, okay, that is we have got 672.54, right? So if you want to convert, if you want to find tens complements, what you have to do, 0.01 you have to add. So once you will add this, so you will get 672.55, right? This is going to be your tens complement. Okay, this is the tens complement, right? So do not use the formula. If you want to use the formula, you can use, but do not use, I will say. If, or you can say that let us take the method number 2, which is not preferable. Suppose you have to find the ninth complement of right, given decimal number 327.45. So this is the digit which represent n equal to 3, and this represent m equal to fractional number of digits, that is 2, right? So what you have to do here is the base is, base is what? Base is 10 here, right? What you can do here is you can use the formula r to the power n minus r to the power minus n and minus n number itself. So r to the power means 10 to the power 3 minus 10 raised to power minus 2, right? And minus number itself, that is 327.45. This is capital N. Okay, this is capital N. What you have to place here. Okay, this is how we can find the nines or tens complement, right? Just by directly applying the formula, right? So this is how we find the nines complement, right? So if you are going to this will be what? This will be 1000 base 10, right? And this will be 0.01 base 10 minus. Now you might be understanding why we are tens complement, because of this. Okay, and this is 327.45. okay, now you have to subtract and you will get 7, okay, directly 54. This is what the nines complement. If you want to find the tens complement, forget about this, right? You have to directly subtract this, you will get tens complement, right? Okay, suppose in the question example again, suppose you have to find the eighths complement of, okay, find eighths complements of 32, 6, and the base is 8, right? So the method method 1 always you have to prefer for the examination. So if you want to find the eighths complement and the base is 8, right? If this guy and this guy is matching, right? So what you have to do, you have to find the seventh complement first. You have to find r minus 1's complement first, then r. Okay, add 1 r 0.1 whatever. Okay, so there is one digit after fraction, so you have to add 0.01, right? So what you can do here is you can subtract this entire number with 7.77, so this will be 32.6, right? So this is going to be giving you 1 5, and this will give you 45.1, and this is what the seventh complement, right? Now if you want to find eighths complement, right? So you have to add 1, so this will give 45.2, right? So this guy is what the eighths complement. This is how we find, this is how we directly we can directly find what, with the help of two-step process. Okay, and but method 2, if you want to go like according to your book, okay, so what you have to do here is suppose you have to find the eighths complement of, right, eighths complement of 32.6. okay, so what you can do here is you can directly apply the formula. So what formula you have to apply here is you have to apply r to the power n minus capital N, right? So directly r to the power n means that 8 to the power n. How many digits are there? There is 2 digits minus the capital N, that is 32.6 itself, right? This guy denotes n, this guy denotes m, and total denotes capital N. So this will be giving you 64 minus 32.6, so it will give you 45.2. The base is 8, remember. Okay, now this will be the base is 8 here. Okay, sorry here, please keep in mind this one concept we have forgotten. You have to convert this, right? So 64, and you have to convert that, so it will be giving you 100, right? So base should be 100, right? Okay, you have to convert this, right? So 8 square means this will be 100, and the base must be 8 here, right? And then this is how you have to do. Okay, so be careful about it, right? So this r will be what you have to convert this in the octal, right? Okay, so do not use this. I will not say do not use the formula. Okay, always go for that concept what I have told you. Use two-step process, right? And the problem next, we suppose we want to find tens complement of the number. Find tens complement, right? Find tens complement of 305. Okay, means the base is 11, so you have to find tens complements. Means you have to find r minus 1's complement, right? So what you have to do here is you have to directly subtract this, right? You have to directly subtract this with 10, means you have to subtract with a. So what is a and 305? So you can subtract, this is 5, this is a, this is 7. So this is the tens complement you have got. Okay, this is very easy, right? And you can also use the formula, but as I told you that as the base is what, as the base r equal to 11, right? So the symbols will be what, 0, 1 and up to a. So this is a maximum digit which you have to subtract, right? Okay, I hope this is clear for everyone. If any base is given and you have to find the decimal, I mean you have to find the complements, right? R minus 1's complement. So you can find like this. Do not use the formula. Okay, right. Next is find the 8th complement of 300, right? Next problem is what? Find 8th complement of 300. Suppose in the examination any kind of question they might ask, read the problem carefully and attack. Here you have to keep in mind the base is what? The base is 8, right? So symbols will be what? 0, 1, 2 and so on up to 7, right? So you have to find 8's complement. So first step will be what? First step will be find 7th complement, right? Find 7th one. So 7, 7, 7, 300. So you can subtract this, right? This is 8 and in the base 8 only you have to subtract, right? Okay, so you can subtract this will be 7, this will be 7 and this will be 4, right? The base 8 you have to subtract, right? And then step 2 will be what? Okay, step 2 means you have to find the 8th complement, right? So find 8's complement, right? So plus 1 you have to do, so it will be 4. Okay, it will be 7 plus 1, that is 8. Okay, but you know that this digit should not be 8 here, it should be less than the base, right? So this will be what? This will be 0 here, right? And this will be 0 and this will be 5. Okay, so this is gonna be your answer for this question. You have to keep this in mind, right? How to add. Suppose we are adding 4, 7, 7, which is in 8, and we are adding 1, which is also in 8, right? What you have to do here is 7 plus 1, 8, right? So 8 can be written as 8 into 1 plus 0. Okay, so because after all you will get this 8 now, so here this 0 remainder should be there, I mean this 0 should be there, right? Now this will be what? So 1 you are getting 1, right? So 1 will be added here, so it will be again 0 and 1 will be added here, so 500. This is how we add in octal system, right? In octal system. So please keep in mind how to add, because this sum should not be greater than the base. Sum should be less than the base, right? Sum should not be greater. Sum of 2 digit. Okay, sum of 2 digit should not be greater than the base. Okay. Right. So the very important complements, which will be asked in your gate examination. So they are the 2's complement or 1's complement, right? And they are basically used in distal system, right? So complements in distal system, what we use always, or computer understand complements in distal system, right? Now we will talk, right? Which in fact your computer also perform. So the base is going to be base is going to be 2, the binary complement. Okay, the symbol will be 0 or 1, that's it. So suppose somebody is asking you that, or in the gate examination the question is like, find 2's complement, right? Find 2's complement of the given binary format, that is 0 1 1 0 1 0, right? They are asking 2's complement, right? So and the base is same. Okay, base is also binary only. So what you have to do, you have to find the 1's complement first, then add 1, right? So the method 1 I am telling you, right? Method 1. So in the method 1, find of 1's complement of the given, right? 1's complement of 0 1 1 0 1 0. Whenever somebody is asking you that, or in the gate examination it is asked that find the 1's complement of this, what you have to do, you have to take the complement of each bit. Okay, so 1 will be 0 will be the complement of 0 is 1, 1 complement is 0, right? That's it. So this will be 1 0 0 1 0 1, right? This is the 1's complement, right? Take the complement of each bit, that's it. That is the 1's complement, right? Take the complement of each digit, complement of each bit. Why we are calling it bit here in case of binary digit, right? So binary digit means binary digit. Okay, so bit, we are taking this and this, we are removing this part, right? If you will remove this part, so you will get digit on bit. Okay, so bit is basically the binary digit, right? We are calling it. Okay, so you have got the 1's complement. 1's complement of any binary format is the, take the complement of each bit, right? 1's complement of 0 1 1 0 1 0, right? Will be what? Will be the 1 0 0 1 0 1. Okay, so that is the the 1's complement. Now you want to find the 2's complement, right? So in order to find 2's complement of this, okay, will be just add 1 here, right? So plus 1 you can add here, so you will get here what? 1 0 0 1 1 0, right? This is the 2's complement of this. Okay, so this is what the concept, uh, if they are asking 2's complements, you have to go for step 1 and step 2, right? 2 steps you have to follow, but I will tell you the trick as well, how to find 2's complement directly. Okay, how to find 2's complement directly. So this is suitable for combination circuits, remember. Okay, this is suitable for combination circuits. Okay, combination circuits. Okay, right. So the method 2 which you have to follow for the examination, right? Whenever they will ask you that find the 2's complement of, okay, find the 2's complement of complements of 0 1 1 0 1 0, right? You have to directly find the 2's complement. So what you have to do here is you have to write 0 1 1 0 1 0, right? Just write like this, and then you have to find the seek bit, right? So you have to move from right to left, right? And the very first one you have got here, this is going to be your seek bit, right? So copy this as it is and copy till the seek bit, right? Till 1, that is going to be your seek bit. Okay, now complement each bit after this 1, right? So 0 will be 1 0 0 1. So this is what the 2's complement of the given binary format. So what you have to do here is you have to copy all the binary digits, right, till the very first one comes into picture, right? And if you're going from if you're seeking one from right to left, okay. And method 3 is the formula. Method 3 is simply the formula, but I will not suggest you to go for the formula, right? Suppose one of the very important problem, right? Very good problem, in fact, if someone is going to ask you that 2's complement of 2's complement of 2's complement of okay, x is x. Somebody is saying that the 2's complement of x is x, right? Means if you're going to take the 2's complement of x, and again if you're going to take the 2's complement of x, so you will get x only, right? So can we try here? So let us see 2's complement. Okay, you have to take 2's complement of x. Okay, so 2's complement of already 2's complement has been taken, that is 2 raised to power n minus x. That is the number here, right? You can say this is x dash. Okay, this part is x dash, because 2's complement means you know that 2 to the power n minus capital N. That is 2's complement formula. So what you can do here is you can say that 2 to the power n minus x dash, right? Okay, this is in 2's complement of, this is the number now, and you have to find the 2's complement of this. So 2's complement of 2 to the power n, and this is x dash, right? Now what you can do here is you can say that 2 to the power n minus x dash means what x dash is, this is entire number now we are considering, so this will be 2 to the power minus n and x. So this and this gone, right? So it will be plus x. So this is proven, right, that if you're going to take the 2's complement of anything, you will get you know the number itself, right? 2's complement of x is x. Very good statement, right? For the examination sake. Okay, so let us talk about the concept called end around carry. Okay, very important concept, right? What is end around carry? EAND, around carry, EAC, abbreviated as EAC, right? So it is a carry obtained when the subtraction is converted to addition, right? When the subtraction will be converted to addition, right? So it is basically the carry only. Okay, it is the carry only obtained when the subtraction, okay, subtraction is converted into addition, is converted to addition. Okay, so let us see where EAC occurs. Okay, so we have to perform subtraction between two binary format, right? So the perform 0 1 1 0 1, right, minus 0 1 0. Okay, so these are the two binary format and we have to find the subtractions. What you have to do here is, we can say that suppose this is given, right? So what you can do here is, you can take the complement of this. Once you will take the complement of this, you can add then, right? So 0 1 1 0 1, right, and plus 1's complement of this, 1's complement of the number of bits are how many? 0 1 1 2 3 4 5. So here you can add two zeros, right? So what you can write here is 0 0 0 1 0, right? So now you can add these two, right? Here they are asking you have to subtract, and but now you can take 1's complement of this, right? So EAC is occurring here, right? I mean, will occur. Let us see how. So this subtraction is getting converted into addition, right? EAC might occur, right? So this is 0 0 1 1 0 1, right? Now 0 1 1 0 1, and you can, what is the 1's complement of this guy? As I told you that you have to take the complement of each binary digit or bit, you can say. So this will be 1 1 1 0 1. Now you can add this, right? Adding these 1 1, right? So you will get 0, carry 1, that is this will be 1, right? And this will be 1 1 0 1, okay, and this will be 0, and you are getting 1 extra 1, right? Extra carry, right? So whenever extra carry is there, right, whenever extra carry is there and you are performing subtraction with the help of 1's complement, right, you are performing subtraction between two binary digits with the help of 1's complement. So what you have to do, this guy is and around carry, EAC, right? So how you're going to get rid of from this carry, you have to add this, right? So this will be giving you the exact answer, right? Okay, this is correct. Okay, so whenever you are subtracting with the help of 1's complement, and if any carry is occurring, so what you have to do here is, you have to add one, that you have to add that one again, right, with the result to, in order to get correct result, right? This is what the EAC concept, right? Keep in mind this. And suppose you are if you are subtracting with the help of 2's complement, right? So suppose you have to perform, okay, perform subtraction using 2's complement. So 0 0 0 1 1 0 1 minus 0 1 0, right? So what you have to do here is, you can write this as 0 1 1 0 1, right, plus directly you can write this as 2's complement, right? So 2's complement of this, 2's complement of 0 0 0 1 0, right? 2's complement of this. Okay, so now what you can do here is 0 1 1 0 1, right, plus what is the 2's complement of this guy? What is the 2's complement of this? As I told you that you have to find the sig bit from going from right to left, this sig bit, right? So copy that 0 1 and then take the complement of them, right? So 1 1 1. Now what you can do here is, you can add them now, because they are in binary, so adding two binary numbers, so 0 1 1 and 1 1 1 1 0, right? So adding these two using 2's complement. Now see, after all, this guy is what, a minus b is given, suppose, right? So you can write this as 2's complement of b. So now what you're doing, you are performing subtraction with the help of complements, right? So that subtraction is getting converted into addition, right? Addition of 2. So this will be 1 1, this will be 0 1 and 0, and here you are getting 1 again, here you are getting 1 again, right? So this EAC you have to discard, this EAC you have to discard, right? So this EAC you have to discard when you are performing subtraction with the help of 2's complement, right? So discard EAC when performing subtraction using 2's complement. A very important concept, right? Very important. These are the concept people always ignore, right? So please keep in mind that. And around carry. What is the meaning of this? Somebody is going to ask you what is and around carry. So you have to tell that whenever we convert subtraction into addition using complements, right? So there one carry occurs, right? That and around carry. But whenever we perform subtraction, using one's complement, right? Consider, EAC when performing subtraction using one's complement. Right? This is very important concept. Okay, you will not get confusion. Confidently you can solve this kind of a question, right? Okay. Let us go ahead, right? In the above process, if EAC is 0, right? Suppose in the above process, okay, if EAC and around carry equal to 0, right? If EAC is 0, what is the meaning of this? If EAC is 0, it means that the result is negative. Result is negative, okay? And if the result is negative means what? It is in complement form. Okay, it is in complement form. Okay. So if you will take the complement of again, so it will become positive, right? If EAC, remember that if EAC is not there means that the result is negative, and again take the complement, right? If you want positive result, right? Okay. Okay. Suppose next problem, let us take next problem. Suppose 0 0 0 1 0, right? This is binary, and minus you have to do is 0 1 1 0 1. This is x minus this y you have to do, right? What you can do here is, now we will be performing subtraction with the help of what? With the help of, always with the help of what? 2's complement only, right? So how we can perform here? So you can say that x plus 2's complement of y. Okay, so x is 0 0 0 1 0, right? Plus, take the 2's complement of this guy. So tick bit is 1 directly, so this is 1 0 0 1. This 2's complement of this. Now add, so 0 0 0 1 0, right? 1 0 0 1 1, add them. So 1 0 1 0 1. Now you're getting 0 as the EAC, right? You're not getting EAC, right? Here EAC is 0 here, right? You're getting this directly. Means what is the meaning of this? The result is negative. As EAC equal to 0, right? So your result is what? Your result is negative, okay? And it is in 2's complement form. It is in 2's complement form. This is very important and deep concept, right? So if you want to get, if you want, convert, okay, so this you have to take the 2's complement of this, right? So to get the right result, right, you have to take the 2's complement of that. So you have got 1 0 1 0 1. Okay, what you have to do, you have to copy this, take the 2's complement of this. okay, because already the 2's complement of this, right? What is 2's complement? This will be 1 1, because sig bit is already 1, that is 1, and 0 means 1, 1 means 0, right? And this will give you 1, right? Okay, and this will give you 0. Okay, so now you can convert this as, after all this is negative, as we come to know that EAC is EAC is 0, means this is a negative number, and you can convert this as in decimal, that is 10. Okay, so it is very easy concept, right? It is very easy concept. Okay, so please keep in mind, if EAC is 0, it means that the number is negative, the result is negative, and you have to take again the 2's complement. Okay, yes, moving forward, one of the very important note you have to keep in mind, one of the very important note, if EAC equal to 0, if EAC is equal to 0, means x is less than y. Okay, means if y is greater than x, okay, then only EAC will be 0. Okay, and if EAC equal to 1, it means that EAC will be 1 when x is greater than y or x equal to y. Okay, these kind of a concept, when numbers are greater, when digits are greater or lesser, will be understood. We'll talk about digital comparator, right? Digital comparator, we'll have to design one comparator which will compare, okay, which are the two digits which are greater than each other, right? So please keep this in mind. EAC equal to 0 when EAC will be 0 when x is less than y, and EAC will be 1, for EAC will be 1, x must be greater than y or x equal to y. These are two conditions. Okay. Always keep this in mind, very important concept I'm telling you. Means you can write a minus b, means a plus, you can write minus b like this. Okay, now what you can do here is you can say that a plus complement of b, so that negative will be hidden, complement of b. Okay, so means performing subtraction with the help of addition using complement concept. Okay, I hope this is clear for everyone. EAC concept. Okay, so what we can do here is we can take example again. Consider the decimal system r equal to 10, suppose is given, right? And the question is like this: you have to subtract 75 minus 21. Okay, so how can you write this as 75 base 10 plus 2's complement, sorry, the complement of, now you don't have to call it 2's or 1's, right? You have to write complements of 21. Okay, right, this is in base 10. Okay, so how can you find complements of anything? You can perform subtraction using 9's complement, you can perform subtraction using 10's complement. So this can be further written as 75 tens plus complement means what? 9's complement of 9's of 21, right, plus 1. So this will be giving you the 10's complement. If you want to perform this subtraction using 10's complement, so you have to add 9's complement. So how can you find 9's complement of 21? 9's complement can be found out by 9921. Just subtract. So it will be giving you 8, right? 7 plus 1, that's 79. This is the tens complement. 75, okay, plus 79. Okay. Once you will add, you will get 54. One EAC will occur, right? EAC 1 will be there, which you have to neglect. Which you have to neglect when you are performing this, as you have to neglect this, right? This is what the tens complement is. So whether you're performing 2's complement, 1's complement, 15's complement, 16's complement, whatever you are doing, you have to follow same concept. Okay. I hope this is clear for everyone. Now let us take one. Okay, so let us take one important problem, right? So you have to perform 21 in the decimal only. It is very easy, but let me explain you how to subtract anything with the help of complement. 2110 minus 75. This is how computer performs, right? With the help of binary digits, computer performs using complements. Okay, it will be very easy for everyone. Manually you can do that, right? And your answer will not be wrong. You don't need calculator, in fact. So 21 base 10, right? So now this is x, this is y. So what you can observe from here is that your x is less than y. So your EAC definitely will be what? Equal to 0. Means that your result will be negative. If the result will be negative, then you have to take again the tens complement of that, right? And put the negative sign. This is what I wanted to explain here. So by looking at the numbers, right, this and this, see which one is greater. If, and definitely, you know, it is lesser, it is greater, so the result will be negative here. What you can write here is that you can write 21 minus 75. Okay, so further you can write this as 2110, right, plus you have to write tens complement of this, right? The tens complement of 75. How can you find tens complement of 75? Finding tens complement of 75 means finding 9's complement first. 9's complement of 75 plus 1 you can do. So 21 plus 9's complement of 75 plus 1 means what? It is very easy concept, right? It is very easy concept, and hopefully everyone might be understanding what I'm trying to convey here. And you will not find this kind of content anywhere, right? Okay. Many people falter whenever they do complements, problem. They do not understand what is the meaning of EAC and all these things. Okay, so please keep in mind this. And around and all, everyone mugs up. Okay, so 9's complement of 75. 75. So 9's complement of 75 means what? 9's complement of 75 means 9975 minus, that is 2. Sorry, this is 4, right? And this is 224. So 24 plus 1, that is 25. This is tens complement. So 25 10. 21 plus 25. 21 plus 25, right? So add this 5 plus 1 6, right? And 2 to 4. And you're not getting any carry. EAC here is 0, right? If EAC is 0, if EAC is 0 means this guy is the result is negative. Okay, as EAC equal to 0, right? The result is what? Negative, and it is in complement form. It is in complement form. Matlab tens complement form, right? Tens complement form. So what you have to do now here is you have to find the tens complement of this and put the negative sign in front of this. What is the tens complement of this? Again, 999 4 6 3 5, and put the negative sign of that. I mean plus 1. So this will be 54, and 54 is the right answer for this question. So this is very easy, and you can perform complements of any base, okay, and that 2's complement, 1's complement, 9's complement, 10's complement, 5th complement, whatever, right? Now how to multiply? So here we will learn multiplication, the binary multiplication and division, right? Binary multiplication and division. Multiplication and division. The very basics I'm telling you, right? How to multiply two binary sets of binary digits, okay, and how to divide, okay. Hmm. So let us take 14 base 10, right? How to multiply these, okay? So you will get 54 in the same base, okay. This is how we multiply in case of that. But in case of binary format, right? So suppose 1110, okay, and the multiplier is what, that is 1011, okay, and these two binary digits are multiplied. So the way you have multiplied, so you have to follow shift and add principle, right? Multiplication using shift and add principle you can do, okay. So you can multiply like shift and add principle, shift and add, whatever you have done for, right, and you can go for like this. So just multiply this, so it will be giving you, this is 1 here, so as it is 1110, right, and okay, again, so you have to forget this, right? So you have to write here 0111, and next 0 is there, so everything will be 0 here. So 0, just shift everything right, from right to left, and then next this will be 0111, and now add 01, okay, and this is 011001, right? Okay, and you can convert this into decimal if you want. So if any decimal number is given, it is very big, okay, so you can convert into binary, okay, and this is how you can perform shift and add. This will you have to follow. And binary division, right? So this was the multiplicand, right? This guy was the multiplicand here, and this was the multiplier, right? Now how to divide, right? So binary division, let us see. Binary division, very easy. The very important concept or very important take home point is to understand the, or to make yourself comfortable with the complement concept, because in the examination, question can be expected from those two's complement, one's complement, any kind of question. So okay, I hope you would be able to do. And if they will ask you perform subtraction or anything, so you can use the complement concept and subtract, okay, using complement concept, right? Okay, so moving forward, perform here, perform 101110, right, given in binary and divided by 100, okay. So means if we convert into decimal, right, so it is 46 base 10 upon 4. This is in base. Method 1 is same, the way you do, okay, the way you do, right. So what you can do here is you can 100 and right here that there is 1, okay, and you will get the quotient, you will get the remainder, right, and everything, and so on and so forth. This is how you can divide, right? It is very easy, okay. We'll not discuss any other methods to get confused, right? So this is what I wanted to discuss in number system and complementary representation, right? Now we'll talk about binary numbers, how they can be represented, right? So binary numbers, what are the representation we have and inside the computer system, right? Binary numbers. So we'll talk about binary numbers of, we'll classify them as two. Okay, the first one will be unsigned numbers, right? Unsigned numbers, and next one will be signed numbers. Signed numbers. Okay, from the name itself you might be understanding. So unsigned number means it is positive always, right? And it has only got the magnitude. Unsigned means it has only got the magnitude, right? Okay, the magnitude, okay, it has not any sign bit or kind of a thing. Means this is n bit here. Okay, this block contains only magnitude, right? So just like 21 to 10101, right, in binary. But signed numbers, they have got little importance and they need little emphasis. We need to emphasize here. So they are of three kind, right? That's why I've drawn three branches here. Signed numbers of three kind, right? The very first one is going to be sign magnitude form. Sign magnitude form. And from here the question can be expected. Magnitude form and one's complement form. And two's complement form. Okay. Binary numbers, right? Unsigned and signed. Binary numbers. Sign magnitude, one's complement form, two's complement form, right? In case of unsigned, there will be magnitude only, and in case of signed means if there is a sign as well as magnitude. Sign magnitude means there will be three kind of representation. One will be sign magnitude, second one is one's complement form, two's complement form. So any negative number can be represented with these complements, right? So in case of sign magnitude form, sign number, I am talking about sign number. My format will be like this. This will be the sign bit. Suppose total is n bit, right? Total is n bit here. The length, this is n bit, right? So one bit will be the sign bit and n minus 1, this part, n minus 1 bit will be the magnitudes, right? This guy will be the magnitude here. Okay. And remember that what is the sign bit? Okay, in the binary here, that 0 represents no, okay, means positive, and 1 represents yes, sorry, 1, right, positive number, right, not no. Okay, or yes, you can say yes. This represents positive numbers, right, and 1 represents negative numbers. So these things you have to keep in mind, right? If there is a 1 associated with magnitude, means that is the negative number. 1, slightly confusing, right? But still you have to accept this concept, right? 0 means positive, 1 means negative. 0 means positive, 1 means negative, right? Okay. So you have to write one note, very important note is here, very important notes. The positive number representation in the above three forms is similar, remember always, right? The positive number representation in above three format, right? Above three forms, sign magnitude form, one's complement form, two's complement form, right? Forms is similar. So you don't have to worry about now. Okay. positive numbers, similar to sign magnitude form only, right? Similar to sign magnitude form, sign magnitude form. This is clear, right? And one more note you have to keep in mind: in unsigned number, where the magnitude is only present, in signed unsigned number, right? The maximum number we can represent using n bit is maximum number we can represent using n bit is what? N bit is 2 to the power 1 minus 2 to the power n minus 1. That is very easy, right? 2 to the power n minus 1. Right? Maximum number using n bit is 2 raised to power. Suppose n equal to 4, so we can say 2 to the power 4 minus 1. The maximum unsigned number will be what? 16 minus 1, that is 15. Okay, this kind of also question can be asked for 1 bit. Okay, right. I hope this is clear for everyone. Okay, so let us take few numbers and represent them in three forms of so let us take some example. Represent, okay, represent plus 21 minus 21 in all three forms of signed number, right? Of signed number representation, right? So you have got sign number representation of three kind. One is sign magnitude form. Second, so the very first is sign magnitude form, right? Sign magnitude form. As I said that in the note itself, right? All the positive number representation will be same for all, right? So the sign magnitude form is what? Sign plus 21, right? Base 10. So it will be what? It is positive. Okay, positive means what? 0 represent positive here, right? So 21 can be represented with the help of 21 means 16, 8, 4, 2, 1, right? So 16 uh 16 plus, okay, 16 plus this plus 1, right? So it will be a 1 0 1 0 1, right? And you have to put 0 here. You have to put 0 here, right? Okay, sign magnitude form means this is showing you the sign, and that is positive here, right? And remaining is the magnitude, right? So this is how we can represent. So this part is the sign and this is showing the magnitude, right? And if it is negative, right? So in case of negative, what you have to do here is you have to put 1. Okay, if it is negative, so so suppose you are writing like this minus 21 in case of sign magnitude form, right? So find out the binary format of 21 and put 1 here, because negative number is there, so it will be 1 0 1 0 1, but this guy will be 1, it will not be 0. Okay, so these are the two representation we can do. Okay, for the sign magnitude, right? Because after all, only here sign we have to change, magnitude will be same. In case of sign magnitude form, this binary bits will be same, binary digits will be same, only the sign will vary, because sign means two signs. 0 means positive, the number is positive, and 1 means negative, the number is negative, right? Okay, let us see in one's complement form. One's complement form, as I told you that the positive number will be same for all, right? So plus 21 can be represented like 0 only. This will show the sign 1 0 1 0 1, right? This is same, right, as the sign magnitude form we have done. And in case of 2's complement also. So but let us take minus 1, you know, this is the minus 21, right? And we have to find the 1's complement of this, represent it, right? What you have to do here is you can write this as 1's complement of 1's complement of what? 0 1 0, 1's complement of this guy. Okay, entire, you have to include this binary sign bit as well, right? So 1's complement of 0 1 0 1 0 1, right? So take the 1's complement of this. You will be taking the 1's complement of this, so it will give you 1. Take the complement of each bit. Okay, so this will be 0 1 0 1 0. So this is the answer. This is the representation in case of 1's complement, including this guy as well, this bit as well. Okay, then you will get the right answer for this question. Now let us represent in 2's complement form. Okay, 2's complement form. The way I'm telling you, so that you will not get any kind of confusion, you know. Many aspirant, many students, while solving digital problems based on complements, they make mistake of this kind, and they feel a lot of pressure, you know. You don't have to feel a lot of pressure. You don't have to feel a lot of pressure, right? Because these concepts are not that tough, because we are doing everything for the computer to understand, right? Okay, so 2's complement is what? Suppose you have to represent 21 in 2's complement. So as I told you that it will be similar as it will be same as the sign magnitude form, that is 0, because plus is there 0, and 21 it's binary equivalent, that is going to be 1 0 1 0 1. Now what you have to do here is, suppose you have to find 21 minus 21 and you have to represent in 2's complement form. What you have to do here is you have to find the 2's complement of plus 21. Okay, so plus 21 means what? You have to take the 2's complement of this, including this bit as well. Okay, 0 1 0 1 0 1, right? So what is the 2's complement of this? Anyone can find, right? As I told you, this is sig bit here, so copy as it is and complement each bit, right, after sig bit. So this will be 1 0 1 0 1. So this one represents this one represents the sign of the number, because sign is negative, that's why there is a 1. This is sign bit. Okay, and this represents the magnitude, right? So this is how we represents. I hope this is clear for everyone. Now, next example or problem you can say is, suppose in the question they are asking that represent minus 225 dot, or you know, decimal point is there 375 given in you know, decimal, right, in 2's complement form. So now the phobia of solving question based on complement, I think, is over. Anyone can do. If somebody is going to watch this lecture after gate examination as well, for the future you know, future preparation, they will not face any kind of problem, right? Okay, so you now you can see here what you have to do here is you have to what you have to do, you have to take 2's complement of plus 225.375. so this plus will give you extra 0, right? Extra 0, and you will convert this into binary format, right? But you have to convert into binary format and add for this guy extra bit, that is sign bit of this. So 2's complement of this. And how to convert this guy into binary, binary, that, right? So you will get here, and you can take the 2's complement of this entire, so you will get the answer here. I'm not going to tell you how to convert this into binary and all. Already I've told you that how to convert. Okay, so let us take more problems here, like find the decimal decimal value of the following, decimal values of the following signed numbers, right? Signed numbers. Okay, find the decimal values of the following signed numbers. What you have to do here is you have to find the decimal values of that, right? They will be giving you the signed numbers, or you can say they will give you the binary format, and you have to find the decimal equivalent of that. So the very first problem is a sign magnitude number, sign magnitude number, right, is given. What is given here? That is given as the 10101, right? So in decimal equivalent here you have to find decimal. So this is given, right? Whenever they are saying this is sign magnitude, right? So you have to consider the first bit is sign here, sign bit, and the remaining is what? The magnitude. Okay, this sign is what? This sign is plus, sorry, this is 1, means this is minus, 1 means minus, okay, minus of this 8421, so means 5, minus 5. Okay, in case of this, how easy this is, right? And B is what? Sign magnitude number. If we sign magnitude number is given, right? A sign magnitude, okay, sign magnitude number means it is given as 0 1 1 1 1. So confidently how you can write? So first bit always consider this is sign bit, and if the sign bit is 0, it means that plus you have to put and take the number that is F, right? Or you can say 15. Okay, right? Next. Okay, now I hope this is clear for everyone, right? Suppose a sign, sign magnitude representation is again given at 0 1 0 1 0 1, right? So the first bit you have to see, this first bit is sign, remaining is magnitude. It is very easy, right? So this guy is telling that is positive number, and this is 16 8 4 2 1, 16 plus 4 20 21, right? So this represents 21. It is very easy, very easy, right? Sign magnitude form. Let us talk about 2's complement format, because that will be asked. So the next problem is what? Next problem is find the decimal value of, find decimal value of a 2's complement. They have already mentioned that this is 2's complement. 2's complement of 2's complement number is given, right? 2's complement number is given, that is 1 0 1 1 0 1. Okay, 2's complement number is given and you have to find the decimal equivalent of this. So 2's complement means what? So this denotes what? This denotes the sign bit, and sign bit is what? Sign bit is 1. Sign bit is 1. If the sign bit is 1 means it is negative number, right? Sign bit is 1, that is negative number. Okay, so if it is a negative number, then you have to take the complement of this. So, and so what you have to do here is negative number and 2's complement. Negative and 2's complement number is this. So method 1, it is a method 1, I'm telling you. What you have to do here is take the 2's complement of this. So 1 0 1 1 0 1, take the 2's complement. What will be here? So this is 1, this is 1, like seek bit is 1, right? The very first you have to seek the bit, the first one, that is 1, as it is copy, and then complement of each bit. So 0, and this is 0 0 1 0, right? What you have got here is you have got this, but now you have got 0 here. So don't think that this is a negative positive number now. So okay, convert decimal part of decimal equivalent of this. So 16 plus, but put minus sign here always, because in whenever it was given, it was negative number it was showing, right? So minus of 16 plus 2 plus 1, that is minus 19. Okay, so this guy is minus 19 in decimal equivalent. Very good question, right? Very confidently you have to do, very confidently. Now method 2 you can do, method 2 also you can follow, right? As they are saying that the 2's complement representation is given, right? 2's complement is given, that is 1 0 1 1 0 1, right? What you can do here is you can directly write this. Okay, you can directly write because of this minus sign, here it will be minus of this. Okay, it will be minus, definitely it will be minus, but let me directly write, right? If there is a minus sign, right, I mean 1 is given na? So it should be minus of 2 to the power 5, I mean 32. Okay, plus, and now you have to take it like 2 to the power 4 plus 2 to the power 2. Okay, plus 2 to the power 0. So this is minus 32 plus 16 plus 8, means this will give you 1910. So this is how also you can convert directly. Okay, this is how you can do. Okay, the weight of this guy will be negative of the position, right? Positional weight, right? So that you will get minus 19, right? So this is a method 2, I'm telling you, right? Okay, so the weight of weight of MSB is minus 2 to the power and minus 1. Weight of MSB in case of 2's complement, minus 2 to the power and minus 1. How many, you can see how many bits are there, right? So there, let me show you how many bits are there. 1 2 3 4 5 6, right? So 6 minus, okay, weight of MSB will be 2 to the power and minus 1. Always keep in mind this in case of 2's complement. Okay, right. Next problem let us take here is that find the decimal value of, find the decimal value of, okay, 1's complement. Number, that is 1 1 1. Okay, 1 1 1 and 0 0. Okay, so they have given you the ones complement here, right, representation, and you have to find the decimal equivalent. So this is also easy. Again, see that this shows you the sign bit, right, sign bit, and this is one means it is negative and ones complement. Okay, ones complement, right, negative and ones complement. So what you will do here is that you have to what, you have to take the ones complement of his, right, take, take the ones complement of that. So 0 0 0 0 1 1, right? And put minus sign of 3. This is the answer. Direct, take the ones complement, ones complement, right? Why I'm taking ones complement of ones complement? Because if there is a complements already given, and if you're going to take again, that complement effect gets removed, right? Okay, so you have to keep in mind that. I think I have done previously as well. So please keep in mind this very important concept. And or if you want to solve using second method, so the method 2, which everyone knows, is that what you have to do here is 1 1 1 1 0 0 is given. So how many bits are there here? The weight of the MSB, you have to take minus of 2 raised to power n minus 1 minus 1, same. I mean, you have to take this minus 1, right, minus 2 to the power n minus 1 minus 1 you have to, okay, in case of one's complement. But in case of two's complement, the weight of MSB will be minus 2 to the power n minus 1, that's it. So this will be minus 2 raised to power 5 minus 1 plus 2 raised to power 4, that is 4 plus 2 raised to power 3 plus 2 raised to power 2, that's it. You will get minus 3. This is also very good concept with the help of these positions, weight. Okay, and you can solve any kind of questions. MSB weight. If someone is going to ask you, let us solve this question. Find the decimal value of, find the decimal value of what, of 2's complement, right, of 1 0 0 0 0, right? Now the moment you see the question, you should not get panic here, because this one is given now, so directly conclude that this is negative and given in 2's complement form. Okay, so how can you remove this 2's complement? Directly you can do here, you can directly take the 2's complement of this, right? 2's complement of this is what? 2's complement, take. So say seek bit is 1 here, right? So copy everything here. Okay, now, okay, you have got already, right? And now minus of this, right? So minus of here, it will be minus of this, so it is minus 16. Okay, directly you can answer. Okay, or you can say in the using method 2, it will be what, 2 raised to power 5, number of bits are 5, so it will be minus of 5 minus 1, that is minus 2 raised to power 4, that is 16. Okay, so directly you can find the answer. If I talk about the properties of one's complement, two's complement number, what are the properties, right? Properties of one's complement and two's complement, right? One's complement, two's complement properties, if someone is going to ask you. So the very first is the sign bit extension. Sign bit extension. This is very important concept. Sign bit extension, right? Sign bit extension. You can extend the sign bit. You can extend the sign bit. Okay, so if you have any question, you can also ask. Right, let me see your comments. Okay. Sign bit extension. In sign bit extension, uh, sign bit extension. What is sign bit extension, right? Consider 2's complement number. Okay. So suppose 0 1 0 we are considering, right? And this is plus 2 in decimal, right? So what you can do here is, if suppose this is plus 2 here, right? So you can extend this sign bit, further. So, and your magnitude is not going to be changing, right? So 1 0 0 is there, so you can put 0 0 like this. You can extend sign extension there, right? As number of bit you want, right? Nothing is going to be changing. Okay, nothing is going to be changing here. Okay, and suppose this kind of a question is given 1 1 0, right? So after all, this is sign bit, right? This is the sign bit. Sign bit. Now what you have to do here is, you have to you have to take the 2's complement of this. Take the 2's complement of this, so it will be 0 1 0, right? So it will be showing -2. Okay, -2, right? So what you can do here is, you can put 0 1 1, and you can put 1 1 1 1, right? No problem is there, right? Means you have to extend sign bit of that sign bit, right? So extension of sign bit will not change anything. Okay, now you can take the 2's complement of this guy as well. So 2's complement of this guy will be 0 0 0 0. Everything will be 0 here, right? And 1 0, so it will give you -2 only. 2's complement, this is a property here, right? You can extend sign bit. And in case of microprocessor also, sign extension is used. Okay, so in case of microprocessor 8086 microprocessor, right, we use there. Right. Okay. Right, so we will meet in the next part again, part 3. Okay, and we'll talk about more concept of complements, and we'll go to logic gates and all. I mean, we'll talk about codes, and we'll talk about overflow condition, overflow, right? Overflow in signed addition, right? This is also important concept, right? So all these things we'll talk. Thanks so much.